Bismillahirrahmanirrahim. Assalamualaikum. Hi, my name is Muhammad Kwan bin Muhammad Asri. My metric number is TE180088. So at here, I'm the first presenter for our group, which is group 5. I would like to present our assignment 2, which is Recyclable Material Classification by using Convolutional Neural Network, CNN. So let's go for the introduction. So for the introduction, the Convolutional Neural Network, CNN, is one way to obtain the dataset and also known as a ConvNet. CNN commonly used to analyze visual, imagery, and are frequently working behind the scenes in image classification. The CNN can take in an input image and assign important learnable weight and bias to various objects in the image and able to differentiate. And last, the pre-trained model that has used in this project is CNN, BEJ44103 and testnet. So then I would like to introduce to the convolutional neural network CNN first. So CNN is a deeply learning algorithm which can take in input image, assigns important learnable weight and bias to various aspects and objects in the image and be able to differentiate one of the others. So then CNN have the ability to learn those filter and characteristic. And the most benefit aspect of CNN is reducing the number of parameters in artificial neural network. Then we go to the methodology. So for the methodology, our group use a flowchart. So for task 1, which is we start then loading data from the Google Drive and then training a sample. After that, we're doing the convolution layer, match polling, then we repeat again convolution layer, match polling, convolution layer, match polling, then dense and CNN based feature learning, training sample features, image clarification, and output clarification result, and end. So then we go to the demonstration at the collab notebook. So for the demonstration, and this is the collab notebook, and this is for the task 1. So we go through for step 1, which is we connect to the Google Drive, which is here. So make sure in our Google Drive, we already upload our folder, which is for the dataset, and inside the folder dataset we have test folder, we have training folder, and we have validation folder. So then for the step 2, we need to feed a dataset directory, and then for the step 3, we create a training and a validation data directory. At here we need to change our directory depend on our database, so Google Drive. So after that we run and we get this result. And then for the step 4, we're doing the construct the CNN model and training model. So at here we using input shape, which is 115, 115, and 3. And then this is the result for the model sequential. And then for the step 5, we pre-process the input data. And so at here, our target size is 115 and 115. And at here, we're using batch size is 8. So the result for this is we found 466 images belonging to 2 classes and found 210 images belonging to 2 classes. And database seed is 8, 115, 115, and 3. And label batch sheet 8. And then for the step C, we start training process. So at here, for the step per push, we use 5, and e-push we use 10, and then last for the validation step, we use 10. So this is the result that we get. And last step is step 7, which is plot the outcome. Then this is our graph that we get for the training and validation accuracy and training for the validation loss. So then we continue at the slide presentation. So next, for the result and analysis. So for the task one, this is our graph that we get for the training and validation accuracy. So at here we can see our graph is optimized, but not exactly optimized. And our training accuracy we get is 95.75%, and the validation accuracy we get 85.38%. And next, for the second graph, which is a training and validation loss. So at here, after we done the calculation, and we get a training loss, we get 14.47%, and the validation loss we get 74.157%. So I think that's all from me. Thank you.
Assalamualaikum and Hi, my name is Nurul Rafiqah binti Razuhi. My metric number is DE180085. For this assignment 2, I want to present task 2. So in this task 2, we need to use transfer learning concept. So actually, transfer learning concept is the reuse of a pre-model on a new problem. So for transfer learning, the knowledge of an already trained machine learning model is applied to a different but related problem. So for this task 2, we need to select two pre-trained model, and then we have decided to choose, which is we choose BEJ44103 and then SNET one-to-one model. So I will present about BEJ44103 model. Okay, actually VGG means Visual Geometry Group. Number 16 is referred to it has 16 layers that have weight, and then VGG16 also known as Oxford net, and then it has total around 138 million parameter. Then VGG16 is that instead of having a large number of hyperparameter, they focus on having convolution layers of 3x3 filter with a straight one, and always use same padding and max pool layer of 2x2 filter of straight 2. Actually, it follow this arrangement of convolution and max pool layer consistently throughout the whole architecture. So as you can see in this picture, in each convolution we'll use ReLU. So actually, ReLU means linear rectifier function, which is an activation function for the neural network. And then in the end, it has two fully connected layers that follow by softmax for the output. Okay, next is methodology. So to do this task, we have followed this flowchart. So first of all, we select our pre-trained model, which is we select VGG16. Next, by using the Google Colab, we need to construct CNN model. So which is we construct our VGG16. So first, we need to load the data from the Google Drive, and then we import the relevant file. After that, we need to construct the pre-trained model. Next is we need to fit the constructed pre-trained model to the structure architecture by using a specific command, and later I will show you. Okay, next is we need to pre-process the input, and then we need to setting the step per epoch and validation step to start our training process. And then to have the result, we need to plot the outcome of our CNN model. So now I will show the demonstration using the Google Colab. So this is Google Colab interface. Firstly, make sure that our notebook is connected by see the icon appear here. Okay, which is RAM and disk. So for the first step, to do this task is connect to Google Drive in which the dataset is stored. Then the Google Colab will read the data and perform the training session. So basically my data is stored like this way, which is from Google Drive, go to my drive, and then go to the Colab notebooks. Okay, after that, it has a dataset folder. Under this dataset folder, it contains 3 folders, which is training, validation, and testing. Okay, so for the training and validation folder, it has 2 types of the data, which is CAN and PAT. Okay, so to connect our Google Drive to Google Colab, just click run button here, and then it will show some note here. So in this case, it shows that my Google Drive is already connected to the Google Colab. Second step, we need to feed the dataset directory. So this orange link here, we actually is from my Google Drive. So to have this, just click here and then click here after copy paste here, and then just paste above here. Then you need to run. After that, for the step 3, we need to create a train and validation data directory. So as you can see here, also show the orange link. So just do the same step as I mentioned before, which is just copy paste for the folder that you want. Okay, then click run button here. After run, it will show the value of the image that we fed to the directory. So it show that for the training, the CAN is 156, for the pet is 310. For the validation, CAN is 77, for the pet is 133. After that, this is the image that my own image that I fed to this directory. So which is 3 image. Okay. Then at this part, we import the relevant library, which is TensorFlow. Actually, TensorFlow is an open source framework that developed by Google Research. And then for the class here, which means a deep learning model that are made available alongside pre-trained weights. Then for the step 4, we need to construct the pre-trained model with BEJ44103. So this is the command that we use, and then click run button here. After that, it will show the whole structure BEJ44103 architecture. And then we need to feed the pre-trained model into the structure architecture, and then click run button here. Then it will show the summary of our system, which is for the first model is BEJ44116. Then flatten the output BEJ before fed the dense model 2 and dense model 3. And then it also shown that the value of trainable parameter and non-trainable parameters. After that, we need to pre-process the input data. So in this command, we set the target size is 150150, meaning that all image will be resized to 150 multiply 150. And then for the batch size, we set into 20. Actually, for target size and batch size, we set for both training generator and validation generator. So then just click run here. It will show that it found 466 image belonging to 2 classes, and it found also 210 image belonging to 2 classes. And then for the next step, we need to start the training process. So at here, we need to set our own value for the step per epoch, which is we set equal to 5. Value for the epoch we set equal to 15, and then the value for the validation step equal to 10. So actually when we decrease the value of the step per epoch, it will be our task or our epoch will be it will be fast running. Okay, sorry, it will be fast running. Then as you can see here, to complete one task, it take actually around 1 minute and above. So for the validation accuracy, we can see that the highest validation accuracy is 100. So after we complete this step, we need to plot our outcome. So as you can see, this is the whole training session that it show that the whole training session, and then the plotted data is actually from 0 to 15. We have this epoch data is because we already set at this line. Okay, so that's all for the demonstration. Next, I will show the result and analysis for this training and validation accuracy and loss. Then the result and analysis. So this is the result for task 2 BEJ44103. So actually, the appropriate number to pass on this existing training data, we use 15 approach and the batch size we use 20. So as a result, it shown the average training accuracy we get 96.75%, while the average validation accuracy is 90.9%. When we compare to the task 1, the BEJ44103 model is better for extracting features from picture with the highest accuracy of training and validation. And then based on the graph, we can define that this model is optimal because the shape and the value nearly meet the requirement of optimal specification. Next, for the average training loss is we get 9.21%, while the average validation loss is 30.17%. So we can say that this loss as optimal even though it has some noise movement in the middle of the training loss and validation loss.
Alright, good morning and hi to Dr. Rafida. I'm docenting. My commentary number is DE1N0047. So now I'm going to continue this presentation by talk about the task 2 for our subject ICS. Okay, so introduction to the dense net. So densely connected convolution network is also known as dense net 1-to-1. So dense net is a sort of convolutional neural network that make use of dense connection between layers through dense block, which connect all the layers. And then it's specifically to improve the decline accuracy caused by the vanishing gradient in high-level neural network. So you can see the diagram here. Okay. So next, for the methodology, I'm going to talk about the flowchart of this task 2 by using DenseNet. So first we have to start our process, and then we have to select the pre-trained type, which is DenseNet. And then as usual, we have to construct our CNN model, which is first we have to load data from Google Drive, and then we have to import the relevant file, and then we have to construct the pre-trained models, and then we have to fill pre-trained model to structure architecture. And then the next one is we have to pre-process the input data, and then by following with we have to set up the step per epoch and validation steps, and also the batch number, it can be set as well to start the training process. And then last but not least, to plot the outcome of the CNN model. So for the DenseNet, so that's all for the flowchart. Okay, now I'm going to show the demonstration in the Google Colab. So first we have to identify the file path, the location path. So inside Google Drive, inside my drive, and then inside the Google Colab notebook. Okay, so there's two files here for the recycle. Okay, so first we have to connect to Google Drive again to make sure everything goes smoothly, and then we have to continue with step 2. We have to feed data set directory, and then create the train and validation data directory. So you can see here the can train length is 156, the pet train length is 310, the can val length is 77, and then the pet val length is 133, the can pet test length is 3. Okay, so followed by this coding. We have to import the TensorFlow, and then step 4 we have to construct the pre-trained model. So in this section there is two coding that we can choose to use, but in this case we are using pre-trained model, so we are using this coding. Okay, so everything's here. The total parameter and non-turnable parameter is 7037504. Okay, so next for this coding, we can see the details here, the layer, and then the flatten 3, then 6, then 7 here. This is the layer type. Okay, so we can see here the total parameters become 15427 and then the non-trainable parameters is so remain the same. Okay, so step 5, we have to pre-process the input data that I mentioned in the graph just now. So we can see here found 466 image belonging to 2 classes, and then found 210 image belonging to 2 classes as well. So the data batch shape is 20, 150, 150, and 3, and the labels batch shape is 20. So Basically, we should start the training process, but this is the process that we run to obtain the optimum graph here. So you can see here the graph here is we call it as an optimum graph because it is increasing from the lower value to higher value, and it's also shown a curve shape here. All right, okay, so let's go back to here. It takes around uh 22 seconds in overall to finish one task or one cycle in the epoch here. All right, okay, so this is the graph here. Same goes to the training and validation loss. All right, so I'll continue with the result and analysis. Okay, so you can see here in task 2 dense net, so the training accuracy is up to 100%, and then the validation accuracy is 99.17%, and then the training loss is 11.36%, and validation loss is 58%. So validation loss here is higher than the previous one. Okay. So for the part analysis, we can know that the greater the validation accuracy, the better the output that we obtain. So meaning that the higher the value of validation accuracy, the better the output that we get. Okay, so our result proven that the outcome of task 2 in two different pre-trained model, which is BGG16 and also the dense net, having higher accuracy than the task 1. Okay, so for the both tasks, we managed to obtain an optimum graph, as we can see that the graph is increased from lower value to higher value with a curved shape. Okay, for the both tasks. And then the setting of the epoch, step validation, batch number, and extra are also bring different effect to the outcome, such as the higher the number of epoch, maybe it will become more stable as well. Okay, so in this case, dense net shown to have better features use efficiency, but it requires heavy GPU memory as well due to the concatenation operation. Okay, so you can see here the CNN we set the epoch as 10, the validation accuracy that we obtain is 85.38%, the VGG is 15 epoch, 90.9% validation accuracy that we get, and the highest one is dense net, the higher the epoch as well, 25, and then we can get the validation accuracy up to 99.17%. So you can see here, if the validation accuracy is lower than the training accuracy, which means we are obtain a optimum graph. Okay, the graph is optimum. Okay, so that's all for me. This is a training loss and training validation loss. So that's all for me. I'll pass it to my another group member. Thank you.
In a conclusion, we have learned how to use Google Colab to accomplish assignment 2, which is to recyclable material classification by using convolutional neural network, or known as CNN. And then we were able to explore more about CNN and discovered the architectures of BGG16 and dense net one-to-one model. Furthermore, the system can accurately detect pictures when presented with image of the PET bottles and aluminum can that provided to us. Next, the CNN has an excellent capacity sequence data analysis, such as natural language processing. And then the CNN consists of two basic operations, which is convolution and pooling. Pooling is used to reduce the dimensional of the feature map from the convolution operation. And then the VGG is an innovative object recognition model that supports up to 19 layers. As we know that VGG has two types, which is VGG16 and VGG19. And it also outperforms baseline on many tasks and datasets outside of the ImageNet. Lastly, the DenseNet was developed specifically to improve the decline accuracy caused by the vanishing gradient in a high-level neural network, and it has higher computational efficiency and memory efficiency. Next is the recommendation. So the recommendation for this assignment is task 1 and task 2 need to be improved the performance of the recyclable material classification system by using CNN. And then we also recommend that to use more frequently these two models, which is VGG16 and DenseNet one-to-one, to solve any similar problems such as classification of others product or other type of thing. And then this recommendation can be used for next assignment, which is use the clear image in the dataset in order to get the best performance use many type of waste material in dataset, and lastly, improve the collect program in order to get the better result. So that's all from our group. Thank you.